Bristol Community College, Mathematics with Dan Avedikian, Math 119, Fundamental Statistics, Section 10.4, Problem 6. This is Section 10.4, Problem number 6. It says that the Department of Motor Vehicles claims that 20% of Americans know how to drive a car with a manual transmission. Manny works at a car dealership on Route 6 in Westport. Out of 100 potential customers, 13 claim that they know how to drive a standard. Manny uses a hypothesis test with a 5% level of significance to test a claim that is actually less than 20% of drivers that know how to drive a standard. What conclusion do you expect Manny to get? So again, this is a hypothesis test. So we're going to start off with the first step of a hypothesis step, which is state the null hypothesis. So you write a capital H for the subscript of 0 for the null hypothesis. You put a colon. Most hypothesis tests have in the null hypothesis mu is the next thing they have, the Greek capital U, which is the symbol for population mean. But in this case, since we're testing a percentage or proportion, we use a P. And next comes some condition of equality. So the null hypothesis will either have equal to, greater than or equal to, or less than or equal to. So in this case, it's equal to. You can use equal to. And then the percent is 20%, but we want to write that as a decimal. So you can write 0.2 or 0.20. You don't need the decimal on the end. 0.2 and 0.20 both mean 20%. So next, you want to write the alternate hypothesis. That's a capital H with a subscript of 1 for alternate hypothesis. We'll put a colon, again, a P, the same number, 0.2, but a different symbol. Instead of equal to, we either put less than, greater than, or not equal to. Well, in this case, which one is it? It's less than. We're testing to see if less than 20% really know how to drive a manual transmission. So we put a less than. Not less than or equal to, just strictly less than. Now, the third step in the process is determine what type of hypothesis test this is. It could be a left-tail test, right-tail test, or a two-tail test. So to determine, what you want to do is look at the symbol in your alternate hypothesis. If it's an inequality symbol, the direction the symbol points in will be the type of test you have. My less than symbol points to the left, so this is a left-tail test. Which means our critical region will be in the left tail or left end of our graph. And how big is that critical region? It says that we want to test at a 5% level of significance, so it's the leftmost 5%. So if we go into that leftmost 0.05, we're into the critical region. That means we'll reject the null hypothesis. If we're closer to the middle, like say 0.07 something or whatever, we will fail to reject the null hypothesis. So that's the thing. Do we go out into the leftmost 0.05 or not? Well, we'll find out. So the next thing you want to do, step 4, is calculate the value of z. And we use the formula z equals x, the number of observed successes, minus n, the sample size, times p, the percent or proportion you're testing for, over the square root of n times p times 1 minus p. So that's the formula for z. So to fill it in, we get z equals x. The number of observed successes is 13. The 13 people who claim that they know how to drive a car with a manual transmission. Minus is next n. The size of the sample. Well, this sample had a size of 100. And then times p, the percent or proportion that we're testing for. 20%, again, as in decimal, is 0.2, or you could write 0.20. It's their equivalent. And then underneath, you have a square root with n, again, size of the sample is 100, times p, the probability that you're testing for, proportion is 0.2. 1 minus p would be 1 minus 0.2. So we can simplify that a little bit. Z equals, so on top it'll be 13 minus 100 times 0.2 is 20, and in the denominator you can have 100 times, well, let's write it all out, 100 times 0.2, 1 minus 0.2 is 0.8. And then I'll simplify that a little bit. So on the next step, we'll have z equals, in the numerator, 13 minus 20 is negative 7. Again, pay attention to the sign, not positive 7, negative 7. And under the square root, if you multiply 100 times 0.2 times 0.8, it comes out to 16. But again, it's still under a square root. Don't forget the square root. So now I can actually do the square root. I'll have negative 7 on the top. Square root of 16 is 4. So if I do negative 7 divided by 4, it will be negative 1.75. The calculator will tell you that. So that was step 4. Calculate z. We got z equals negative 1.75. The fifth step is look up z in the standard normal probability chart. So I'm going to look up negative 1.75 in that chart that's at the end of this homework. So the first thing you want to do to look up something in the chart is write it so that it has 2 places after the decimal. This already has 2 places after the decimal. So the first part of that is easy. Next, split the number into 2 parts by pulling off the rightmost digit. So that 5 just comes off to the side. After you pull off the rightmost digit, you put a 0.0 in front of the rightmost digit that you pulled off. And then after that, the digits from the left, negative 1.7, will tell you what row of the chart to look in. And the digit from the right with the 0.0 that you put in front will tell you what column of the chart to look in. And where the row and the column intersect will be your answer. Now again, make sure you're looking in the negative part of the chart. There's a positive page, negative page. This is negative 1.75. Make sure you're on the negative page. So the negative 1.7 row will intersect with a 0.05 column at 0.0401. That's the number that comes out of the chart. So now the question is, what's our conclusion? That's the final step, step 6. Do we reject the null or fail to reject the null? And it depends on whether or not we went into that critical region, and we did. So the critical region is the leftmost 0.05. Well, we went 0.0401. So we are into the critical region. That means our conclusion will be to reject the null hypothesis. If we reject the null hypothesis, that means we feel the alternate hypothesis is the statement that's more likely to be true. It's not a guarantee to be true unless you test all the drivers there are, which wouldn't really be feasible. But it's more likely that less than 20% really know how to drive a manual transmission. So the final conclusion is reject null.